Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 13, Section 1, Polynomials. And this is just going to be a very basic introduction to polynomials. Polynomials are basically taking variables and constants and adding and subtracting them together. It's the sum or the difference of variables and constants. Polynomials can have anywhere from one term to any number of terms. You could have 100 terms, you could have 50 terms. In the example you see here, we have 3 terms. And as long as your terms are being added or subtracted, then you have a polynomial. There are a couple of things you need to be looking for when you're trying to determine whether or not an expression is a polynomial, and we'll get to those a little bit later. But first, I just want to take a look at a polynomial and look at the different pieces. So if we take a look here, just a refresher on terms. 4xy squared is one term because it is separated from 3x by this plus sign. Because remember, polynomials are the sum or difference. You're adding or subtracting variables and constants together. The multiplication piece that is indicated up here is coming from the fact that oftentimes in terms, your terms themselves will have multiplication within them. 4xy squared means 4 times x times y times y. But that is all considered one term because when you multiply all those together, they represent one number. Before you can add or subtract, you have to multiply first. So the first thing we technically have to do in this problem is multiply 4xy squared. Of course, we have to do y squared first and then multiply 4 times x times whatever y squared is. And at that point, it will represent one number. So the product of 4xy squared will be added to the product of 3 times x. And then you will subtract 5. So that's why this is considered one term, because this right here will be added to another number. This right here will be subtracted by another number. And then this right here is going to be subtracted from a number. So those are your 3 terms in this case. Anytime you see a plus or a minus sign, that's basically telling you we are starting a new term. Okay, so you have your first term here. You see the plus sign, you know another term is starting. You see the minus sign, you know another term is starting. And so you have a total of 3 terms. So basically the word polynomial, just to break it down, you have the word poly, which means many, and nomials, or nomial, which typically means number. In this case, we're using it as term, which is, so many terms. Each term technically represents one number. Like we discussed before, 4xy squared represents one number, 3x represents one number, and 5 represents one number. So you're talking basically what this technically means is many numbers, but you could also translate it as many terms, because in this case when we're referring to a polynomial, we're referring to many terms, and each term represents a number. The different pieces of the polynomial, you have constants, which are just numbers like 3, -20, or 1/2. The reason why they're called constants is because they have a constant value. 3 is constantly, it always has a value of 3. -20 always has a value of -20. 1/2 always has a value of 1/2. Variables are called variables because their value varies. Okay? X could be 0.22 in one expression, while it could be 17 in another expression. So their value varies. And then of course you have exponents. And those are okay to be in a polynomial as long as your exponents are not negative or fractions. You can have exponents that are fractions and you can have exponents that are negatives, but not in a polynomial. A polynomial can only have positive whole number exponents. So as long as your exponents are positive and whole, you've got a polynomial. There are the 3 most common types of polynomials you're going to see are monomials, binomials, and trinomials. Basically, a mono means 1, bi means 2, and tri means 3. So you have one number, two numbers, or three numbers, or in other words, you have one term, two terms, or three terms. So here is a monomial. You can see there's just one term. That is technically a polynomial. Here is a binomial. This has two terms. It has 5x and it has 1. This is a trinomial. This has three terms. You have 3x, you have 5y squared, and you have 3. Now, obviously there are many other types of polynomials. You can have 4 terms, you can have 5 terms, you can have 2,000 terms. Technically all of that's possible, but these are just the 3 most common, and we call them monomials, binomials, and trinomials. So the question is, can you identify a polynomial? What are you looking for? Okay. So down below here we have some examples that are polynomials. 3x by itself is just one term. Technically it's a monomial, so yes, this is a polynomial. Here we have x minus 2. We have a binomial here. We have x and we have 2, so this is a polynomial. Here we have a binomial. We have negative 6y squared as one term, and we have 7/9 x as another term. Here we actually have what's known as a quintinomial, or a polynomial with 5 terms. You have 3xyz as one term, 3xy squared z as another, 0.1xz as another term, 200 as another term, and 0.5 as another term. Then down below we have a binomial once again. And yes, 1 is a polynomial. It has just one term, which is a constant, and that is the number 1. Number 1 is a constant, and so yes, it counts as a term for a polynomial. Some things that aren't polynomials, just to give you a heads up, these are the key things you're looking for. You can never have a division sign. You can't have like a fraction with the variable in the bottom, because you can't divide with a variable in the bottom. If I have 1 over x, I have no idea what that is equivalent to. I don't know if that's going to be 1/2, 1/3, it could be 1/10. I can't divide that. So I can't have a variable in the bottom of a fraction, period, ever. I can't have any division in a polynomial, and so especially when the variable is in the bottom. 3xy to the negative 2 is not a polynomial because the exponent has a negative in it. When the exponent has a negative in it, that essentially translates to the y to the negative 2. If you remember correctly from chapter 4, y to the negative 2 will actually be flipped to the bottom, and this is actually this term here is actually equivalent to 3x over y to the positive 2. So your variable is actually in the bottom there. And you also cannot have the square root of a variable. You can have the square root of an actual number, such as down here. The square root of 2 is allowed because the square root of 2 is a constant. The square root of 2 represents an actual number, 1.4142. So that does represent a constant, so the square root of an actual number is allowed because, for example, the square root of 25 is 5, so the square root of 25 is just another way of saying 5. So technically it's just technically it's just a constant. The only time you can see division or fractions with variables in them is when the variable's on top, because when the variable's on top, you can actually turn that into a multiplication problem. So for example, x over 2 is the same thing as 1/2 times x, and that is allowed. 1/2 x is allowed. Whereas if the variable is on bottom, you can't do that. So that is that. So here's another example where the variable is on top, you can take 3x over 8, and it's the same thing as 3/8 x. So basically, what you want to take from that is the variable is allowed on top of a fraction, but not on the bottom, and the variable is not allowed inside a radical sign, or in other words, a square root sign. So you can't have the variable in the bottom of a fraction, you can't have the variable in a square root sign, and you can't have negative or fractional exponents. So I can't have a -2 as an exponent, and I can't have a 1/2 as an exponent. Otherwise, this is not a polynomial. Polynomials can have lots of terms, but it cannot have an infinite number of terms because a polynomial has to at some point stop. In order to be an expression, it has to at some point stop. Infinite technically means it goes on forever and ever. In other words, you would never run out of terms. Variables, polynomials can have no variables at all. You could just have the number 21, and that is a polynomial. You can just have one variable throughout the whole thing. So in the example here, you have x to the 4th, 2x squared, and you have x. So you can have the same variable repeating throughout the whole thing. Or you can have two or more variables. You can have xy to the 4th minus 5x squared z. So this has actually 3 different variables in it, and that's okay as well. The last thing I want to touch upon in this video is the degree of a polynomial. So we've discussed what a polynomial is and how to identify it, and the different types of polynomials such as binomials, trinomials, and monomials. And we've identified how to determine whether or not it is a polynomial, if it is or isn't a polynomial. So the last thing I want to talk about is the degree. How do you find the degree of a polynomial, and what exactly does that mean? The degree of a polynomial is simply the sum of the exponents of the largest term. So for example, if we take a look here at number 25, the largest term is going to be c to the 3rd power. And so since the exponent is 3, then the degree is 3. There is only one term in number 26, and that is m n to the 5th power. The degree here would actually be equivalent to 6. And the reason for that is because we have to take the sum of the exponents of the entire term. This is the entire term that I've highlighted. While you don't see it, the m has an exponent of 1. And so 1 plus 5 gets you 6. So there's a degree of 6. Over here on 27, there is a degree of 5 because the x has a 1 and the z has a 1. And so 1 plus 3 plus 1 is 5. If you take a look at number 29, this has a degree of 0. If you have a constant, we don't, it counts as 0. The only exponents you're adding are exponents of variables. You don't add the exponents of constants. If we take a look at 31, this one's going to have a degree of 10 because you have a degree of 6 on C, you have a 1 on the D, and a 3 on the E. So you have a total of 10. Trying to find right here. If you take a look at number 35, again, going back to the example before, constants, exponents don't count. So this would only have a degree of 5 on number 35. You would not have a degree of 6 here because you don't count anything with the constant. You just look at the variables, and there's only one variable in this term, which is b, and that has an exponent of 5. So the degree of this whole expression, I don't know if I've emphasized that well enough, the whole expression, the degree is 5. Up here, when I said the degree was 5 on number 27, the degree of the whole expression is 5. Over here on number 25, I said the degree was 3. The degree of the whole expression is 3. Remember, you're looking at the largest term, which typically is going to be the term that's out in front if your polynomial is in standard form, You will not be dealing with any polynomials that are not in standard form this year. All right, so if they're not in standard form, they could be all mixed up. So you may have your c in front, and the 1 could be the second number, and the c to the third power may be the last number. That would be a non-standard form. Typically, standard form, you go from the highest degree down to the lowest degree as far as your terms go. This term has a degree of 3. This one has a degree of 2, 1, and 0. If we take a look here, we have a degree of 3, degree of 2, degree of 1, degree of 2, and a degree of 0. Part of the reason why this one came after the 5c is because of the subtraction sign. You can't flip-flop with subtraction, so they had to stay in order. Any questions on this? Please pause the video and raise your hand, ask for some help. Hopefully you took notes. There was a lot of information in this video. If you didn't take good notes, go back and take them now. Skim back through the video, rewind it, rewatch it, and pause it when you need to take good notes. Next section will be chapter 13. Next video will be on chapter 13, section 2.